Queen Charlotte had all power over the Ton, until Lady Whistledown's gossip papers began flooding London and controlling the Ton. The Queen was angry, but since no one knew who's behind these papers, her anger stayed constant with every issue. Her anger can be represented mathematically as the mass of each gossip paper times the velocity at which it reaches the Ton. And since her anger stays constant, the derivative of her anger with respect of time must be 0. But the question is, how can we prove this mathematically?
We can thank Noether for that.
Theorem states that every symmetry implies a conservation law.
So let's go looking for that symmetry.
Using Lagrangian mechanics that look at objects through their energy rather than their forces. Lagrangian is the kinetic energy of an object minus its potential energy, rewritten as mv squared by 2 minus potential energy.
The potential energy is being represented by the potential of the gossip paper being stopped by the Ton, which in this case is constantly at 0, because no one knows who writes the gossip papers.
This is directly linked to Noether's theorem, which states that any object with a constant potential energy also has translational symmetry.
Wait a minute. Which conservation law does translational symmetry imply?
Remember mentioning how the Queen's anger stayed constant and how that represents momentum? Well, that's exactly it. Momentum is what's conserved when there's a translational symmetry.
But how exactly do we show that mathematically? We can use the Euler-Lagrange equation as a parallel to the Suvat equations we use in Newtonian mechanics. Applying the partial derivative operation would transform mv squared by 2 into just mv, and then potential energy, which is 0, would be subtracted from that. We can then plug everything back into the Euler-Lagrange equation and say that d dt mv equals 0, which proves that momentum is conserved when there's a translational symmetry.